Now, Boeing has begun a production of the first F-47 sixth-generation stealth fighter for the US.
I'm thrilled to announce that, at my direction, the United States Air Force is moving forward with the world's first sixth-generation fighter jet.
Across the rapidly changing landscape of military aviation, the United States Air Force is actively shaping the future with new aircraft designed to address rising technological challenges and intensifying global competition. Recent developments confirm that the Air Force's modernization drive includes a new generation of warplanes, among them advanced stealth fighters and heavy bombers, all reflecting a decisive evolution in strategy and capability. With Boeing commencing work on the first of the Air Force's sixth-generation stealth fighters, the F-47, which is scheduled for its initial flight in 2028, the Pentagon has also acknowledged that at least 5 innovative warplane projects are advancing beyond classified development. Within this portfolio, a new heavy bomber is emerging as a central component of the Air Force's plan to maintain a technological and operational edge. More than just an advanced airframe, this new bomber is a culmination of decades of combat experience, technological advancement, and strategic foresight. The Air Force's vision for its future bomber force reaches well beyond incremental upgrades. By mid-decade, the makeup of America's strategic bomber fleet will undergo significant transformation, driven by the introduction of platforms featuring artificial intelligence, digital connectivity, stealth, and the potential for deploying hypersonic and long-range standoff munitions. This new approach is tied to the development of not only the F-47 fighter, but also bombers that are optimized for carrying advanced weapons and operating seamlessly within modern, network-enabled battlespaces. This shift matters because evolving threats demand more than improvements in speed and stealth. They call for integrated, multi-domain capabilities that provide resilient deterrence and combat readiness. The arrival of a new generation of heavy bombers marks a substantial step in ensuring American air power remains credible and flexible in the face of modern peer adversaries and emerging global challenges. The quiet revolution, secret projects take flight. Within secure facilities, the U.S. Air Force is orchestrating a quiet but profound transformation of its airborne arsenal. At least 5 previously secretive warplane projects have moved forward from theoretical design to practical engineering, each contributing a unique aspect to a cohesive, networked force structure. These developments encompass advanced strike drones, stealthy fighters, and long-range bombers, each conceived not simply for superior flight characteristics, but for a new era defined by integrated multi-domain operations. Central to this approach is the reimagining of the heavy bomber's role. While program names and specifications remain classified, Air Force leadership has consistently articulated a vision that emphasizes the integration of technologies like stealth, artificial intelligence, advanced crew survivability systems, and large payload capacity with state-of-the-art propulsion systems. A particular focus in next-generation bombers is the deployment of hypersonic weapons and standoff munitions, with the goal of maintaining striking power at extended ranges and compressing the timelines in which adversaries can respond. Where previous generations of bombers evolved incrementally, the bombers now in development are being conceived from the start, with requirements for greater adaptability, survivability, and capability within highly contested environments. Boeing's progress on the F-47 fighter demonstrates the Air Force's commitment to these goals. The replacement for the F-22A Raptor, the F-47, is being designed to exceed benchmark capabilities for survivability, modularity, and rapid system upgrades. This same deliberate, flexible design ethos extends to the bomber force, where secrecy and operational security guide the measured disclosure of capabilities and tactical intent. Importantly, these new aircraft do not operate in isolation. They are expected to work in concert with unmanned systems and advanced fighters, linking sensors and shooters across domains. As AI-assisted manned and unmanned assets take on more roles, the evolving bomber fleet will serve as a hub for integrating new technologies and revising long-standing methods of strategic air warfare. In this context, the broader transformation of the bomber force becomes apparent. It is less about the introduction of individual, cutting-edge airframes and more about integrating technology, doctrine, and adaptability into a force that is ready to meet future threats with speed and resilience. Engineering the future, inside the next-generation bomber. The new generation of heavy bombers represents a leap beyond prior benchmarks in aviation engineering. These platforms are being designed around a combination of stealth and advanced propulsion, offering the ability to operate at long ranges and integrate seamlessly with both current and future weapons systems. While specific details are not publicly disclosed, contextual clues suggest a focus on aircraft capable of carrying and launching hypersonic weapons as part of a mission set that includes standoff and air-to-air munitions. Distinguishing the new bomber from legacy platforms, such as the B-2 Spirit or B-52 Stratofortress, is its planned ability to support an expanded operational envelope. The B-52 and B-2, for example, were built respectively for endurance and penetration, but operated within the technological limitations of their times. Looking ahead, the next-generation bomber will be tailored for highly survivable, networked operations, leveraging stealth and digital connectivity to stay ahead of adversary defenses. Key design goals include integrating materials and features that minimize detectability, such as radar-absorbing skins and internally housed weapons, as well as systems to mitigate the heat and mechanical stress associated with potential hypersonic munitions. Engine development, although always an engineering challenge, will be tailored to achieve endurance at efficient cruising speeds, with the capability to rapidly reposition if necessary. A core area of innovation is survivability. The new bomber is expected to embed sensor fusion technologies, enabling it to aggregate data from satellites, forward-deployed fighters such as the F-35, and its own advanced sensors. This networked approach greatly enhances situational awareness and allows for rapid threat detection, dynamic mission adjustments, and autonomous countermeasures, features increasingly necessary against today's sophisticated air defenses. The trend toward semi-autonomous operation is also a significant aspect of this development. As communications grow more contested and adversaries pursue jamming or cyber attacks, greater reliance will be placed on AI-driven systems for managing in-flight variables, monitoring threats, and adjusting tactics. The emerging bombers are being designed with this environment in mind, enabling greater mission resilience even in degraded or denied communications scenarios. The next-generation bomber's payload flexibility further reinforces its role as a backbone of the future force. In addition to delivering hypersonic strike weapons and precision-guided standoff munitions, some design concepts incorporate the ability to launch air-to-air missiles. This capability would allow the bomber to operate more independently, defending itself as necessary and maintaining the unpredictability that is central to modern air power doctrine. Collectively, these advancements produce an airframe that is more reliable, survivable, and adaptable than any previous U.S. bomber. This engineering roadmap is steering the Air Force toward a strategic posture optimized for rapid response, integrated operations, and sustained deterrence. Shifting doctrine: the bomber in tomorrow's battlespace. The U.S. Air Force's historical reliance on a diverse bomber fleet has centered on two foundational concepts: credible deterrence and flexible global reach. These principles, refined throughout the nuclear and post-Cold War eras, are now being reinterpreted for a future in which contested airspaces, advanced defensive networks, and rapid decision cycles set the operational pace. The next-generation bomber's anticipated speed and range, potentially exceeding 2,000 miles without refueling, present a marked departure from older approaches. Legacy bombers such as the B-52, while capable and enduring, require extended flights and regular refueling, exposing them to increased risk in peer conflict scenarios. In contrast, the emerging bomber's ability to project power swiftly and over great distances compresses adversary response time and enhances operational unpredictability. A major strategic concept is integrating the bomber's operational role with assets such as the F-35 Lightning II. The F-35's sophisticated sensor suite and forward deployment capabilities allow it to act as a sensor node, relaying targeting information back to the new bomber. This networked approach blurs the division between fighters and bombers, allowing the two to complement each other in complex air campaigns where both survivability and lethality are vital. The versatility of the new bomber in carrying multiple types of weapons, including air-to-air, as well as conventional and standoff munitions, mirrors the Air Force's growing emphasis on multi-role and multi-domain operations. No longer designed solely for deep strike against fixed targets, the bomber now embodies a capability to support air superiority missions and adapt to a wide variety of operational roles as directed by dynamic battlefield requirements. Artificial intelligence is central to enabling these flexible operations. By fusing sensor data and providing advanced targeting recommendations, AI supports rapid, informed decision-making at both the individual aircraft and broader force levels. Whether paired with manned or unmanned assets, the new bomber's AI-driven systems will help to ensure platform survivability and mission effectiveness, even in unpredictable and rapidly changing scenarios. The result of these doctrinal changes is a force structure that is more agile, harder to predict, and more difficult to disrupt. Attributes that are increasingly valuable as adversaries invest in technologies designed to deny U.S. access to critical regions and complicate traditional concepts of deterrence. Developing the arsenal, hypersonic weapons, and munitions. A defining characteristic of the next-generation bomber is its integration with America's most advanced weapons, especially hypersonic and long-range standoff munitions. These weapon systems, still under active development and fielding, fundamentally reshape the combat potential of the bomber fleet. Hypersonic weapons, traveling at speeds in excess of Mach 5, are notable for their combination of velocity, maneuverability, and relative invulnerability to many established air defense systems. When paired with an advanced bomber operating at range, hypersonic weapons enable rapid response against high-value or time-sensitive targets deep inside contested areas. For defenders, the shortened warning time and compressed response windows greatly complicate efforts to intercept or neutralize an incoming strike. Standoff munitions augment the bomber's flexibility by permitting attacks from outside the effective envelope of enemy air defenses. These precision-guided weapons can be deployed in a variety of scenarios, forcing adversary planners to account for the risk of attack from multiple directions and ranges, and complicating their own resource allocation for defense. The potential to equip the bomber with air-to-air missiles offers yet another dimension of operational adaptability. Historically, bombers have relied on speed, altitude, and stealth for survival, rather than direct engagement with interceptors. The ability to carry air-to-air weaponry would offer new self-defense and mission sustainability options in environments where threats from hostile aircraft or high-speed missiles are particularly acute. This expanded arsenal further supports the Air Force's drive for mission flexibility. Whether launching nuclear or conventional weapons, supporting maritime operations, or providing sensor and relay capabilities in contested information environments, the next-generation bomber is being prepared to serve as a Swiss Army knife for strategic missions, seamlessly shifting between tasks as the situation demands. Ultimately, the effectiveness of these weapons platforms will depend on their integration with advanced targeting and command and control systems. As AI becomes more central to weapons management and tactical planning, crews will be able to handle increasingly complex mission profiles, responding in real time to the evolving conditions of modern warfare. AI, autonomy, and the future warfighter. The transformation underway in the Air Force's bomber force is inseparable from parallel advances in artificial intelligence and autonomy. The next-generation bomber is expected to rely increasingly on AI for flight management, threat assessment, sensor fusion, and weapons employment, providing a significant boost in mission adaptability and crew survivability. The use of AI does not eliminate human participation. Rather, it allows crews to focus on high-level command decisions, with AI systems supporting routine tasks, rapid calculations, and dynamic response to threats. Automated systems can manage flight performance and monitor for emerging hazards, enabling the bomber to continue its mission even in environments where communication is degraded or denied. This technological progression is significant in the context of rapidly intensifying electromagnetic and cyber warfare. AI-enabled aircraft can process new mission instructions, adapt to changing threats, and maintain operational security even when cut off from centralized command. Enhanced sensor fusion further allows the aircraft to aggregate threat data across electromagnetic, infrared, and radar spectrums, strengthening its resilience to stealth-countering technologies or jamming attempts. The trend toward integrating manned and unmanned assets continues as well. The concept of loyal wingman drones, remotely operated or AI-driven companions flying alongside manned bombers, gains new relevance as networked, semi-autonomous assets work in conjunction to improve survivability and operational reach. The next-generation bomber is expected to operate within such frameworks, coordinating its actions with a constellation of supporting platforms and ground networks. The new paradigm thus shifts the Air Force's operational approach from centralized linear command structures toward distributed, adaptive force packages. This not only increases mission resilience, but also offers new options for responding to adversary actions and rapidly exploiting tactical opportunities. The modernization of the bomber force is critical for sustaining the United States' strategic deterrence posture in a security environment increasingly defined by peer competition. As potential adversaries invest in integrated air defense systems, electronic warfare, and their own advanced missile platforms, the effectiveness and survivability of the bomber fleet become even more salient. The long-range, high-speed capabilities of the future bomber are designed to offset emerging threats, allowing the United States to project power and hold targets at risk, even as adversaries seek to impose access denial strategies. In the event of heightened regional tensions, these new bombers, operating from distant bases, could strike or respond more swiftly, reducing the likelihood that attacks could be disrupted or preempted. The strategic calculus is further affected by the uncertain mix of threats facing American interests worldwide. The flexibility and payload diversity of the new bombers enable rapid adaptation to different theaters and mission requirements, reinforcing the credibility of Air Force deterrence and response options. Critically, the new platforms are not expected to replace all legacy bombers overnight, but to complement them as part of an evolving, layered force. Integration with assets such as the F-35 and unmanned strike drones allows planners to leverage existing strengths while gradually phasing in new operational concepts and technologies. In high-intensity conflict, this means more options for dispersal, unpredictability, and strategic surprise. The overall objective is not an arms race for its own sake, but the preservation of credible deterrence. The ability to convince adversaries that aggression would be met with prompt, effective, and technologically superior responses, thereby reinforcing global stability. The road ahead, from blueprint to operational readiness. The schedule for transitioning the Air Force Bomber Force remains ambitious. By 2025, new aircraft, innovative sensors, and advanced munitions are expected to begin entering service, even as the F-47 fighter moves ahead toward a projected first flight in 2028. These efforts reflect the urgency of national defense modernization and the drive to maintain air superiority in the face of increasingly capable adversaries. However, the introduction of such advanced capabilities also brings new complexities. Training the crews to operate next-generation systems, integrating AI into cockpit design and mission planning, and developing operational concepts suited to unprecedented levels of autonomy all require significant institutional adaptation. The Air Force will need to revise its doctrines, logistics chains, and sustainment plans to fully realize the potential of these new platforms. Fleet size and resource management loom as important factors as well. With increased capability often comes increased cost and complexity, and decisions about procurement, basing, and long-term support will play a decisive role in shaping future air power options. Rather than relying on massed bomber formations, the future may be defined by relatively fewer, but vastly more capable, flexible multi-mission aircraft. International partnerships and joint operations will take on new importance as well. Leveraging the new bomber's capabilities to support allied missions, share sensor data, and participate in joint campaigns will be vital to maintaining a credible and effective presence in global security architectures. Nevertheless, the ultimate test lies in the ability to transform technological innovation into real-world readiness and deterrence. The Air Force's modernization, represented by the Next Generation Bomber program, embodies this commitment, translating years of research, engineering, and strategic thinking into platforms ready for operational deployment. As the Air Force's next-generation platforms transition from design to reality, the renewal of the strategic bomber force stands as a symbol of both technological achievement and enduring security priorities. The interplay of advanced stealth, AI integration, long-range strike capability, and operational flexibility defines not just a new aircraft, but a foundational shift in American air strategy. Ongoing construction at Boeing and parallel refinement of doctrine and training underscore the seriousness with which these capabilities are being fielded. While significant technical challenges and strategic questions remain, the future-oriented bomber program demonstrates the Air Force's resolve to maintain an effective, credible, and agile deterrent. By advancing these next-generation systems, the United States sets a course for continued air power relevance, addressing the realities of emerging threats while preserving the ability to adapt in a rapidly changing world. The strategic advantage of the future will not rest on individual machines alone, but on the capability to bring together technology, doctrine, and people in service of clear and achievable objectives. The evolution of the Air Force bomber fleet thus represents more than a moment of technological progress. It is a marker of ongoing commitment to security, adaptability, and leadership in the skies for the challenges that lie ahead.